All right, this is an effort to get rid of some of the homework questions that have come up in chapters 5, 6, 7, and 8. There's 4 chapters here. And so this is before the exam. So you guys can at least see some of it here. So let's jam with it here. So these are the questions that have come up from chapters 5, 6, 7, and 8. I'm going to just go through them real quickly here. So first things first, let's go. So chapter 5, this is what we have here. And this, I just took a student's score here. And so how do you pick this? This is chapter 5. And it's called Continuous Random Variables, I believe chapter 5 is. So anyways, let's go for it here. It's really just distribution of numbers, how we think about distribution. So there's called uniform distribution, and there's called exponential distribution. That's the kind of the two main ones here. So we have a number generator that picks numbers from 16 to 72. And it picks it in a uniform manner. So there's no pattern to it here. And so the question is, what's the mean for this here? So the mean is, since we're picking numbers from 16 to 72, all we're going to do is we're going to add up the numbers themselves and then divide by 2, and that would give us the average. That's where that 44 comes from. Okay, the rest of it, I know I'm not going to do all the problems here. I do want to focus on the ones that were wrong, because these are the students that asked for them. Most of the time it's been like the A and the B students that's asking for, a couple of C students that asked for a couple of things here. So let's go for it here. So F, how do you get this? What's the probability that the number that you want is going to be greater than 36, given, that's the little given piece, given that the X that's already been chosen is less than 58. So let's kind of do this here. So let me rewrite it over here real quick here. So that's the condition. There's this little condition marker. All right, so we go with it here. We got 16 all the way to 48, or sorry, 58. In fact, I think we should think about 57 technically, right? Because it says less than 58. So the number generator is going to pick 16 all the way up to 57. Sorry, 57. So in that case, 57 minus 16. So the range that we have really is 41. And so if our probability is going to be 1, our range here is 41. This is the length of a rectangle. So that means the width of the rectangle has to be 1 over 41 to make this whole just one whole piece. This is just 1. All right, then the question is this. What's going to happen, or what's the probability if X is going to be above 36? All this little good stuff right here. So if you start counting, you can start counting and how many numbers can I pick above 36? You can go 37, 38, 39, 39, 40, 41, 42. You can count all the way up. And you should get yourself just this little subtraction right here. So there should be 21 numbers that you should be able to pick, starting at 37, going to 57. All right, so that is the case. We're going to take this number here called 21, because that's how many numbers are left here, and then we're going to multiply it times 141, or technically divide by 41. So 21 divided by 41, and whatever the answer is, that should be it. So 0.5238. In fact, I have it circled. I think it's actually not correct. Great. This is the first problem we have here. I'm going to check this a second time, actually turn it in. The numbers are just slightly off. So what I'm getting on my calculator here. All right, let's go on. Let's go on to the next one here. This is what's set up here. So the next problem in chapter 5, this little piece right here, suppose same exact concept. If you really want to concentrate on uniformly distributed, that's the one that you want to really be mindful of. It's uniformly distributed. We've got this little rectangle that's happening on our hands. And so newborn fawns, here it is. They range between 2.1 kilograms to 3.8 kilograms. That's what I have here. And if you subtract the two from each other, you get a 1.7. So if I'm going to make my little probability rectangle of 1, that means the height or the width of this little rectangle is going to be 1 over 1.7. So there's my little rectangle. This right here has a probability of 1. All right, so if I'm going to cut this right at, let's see, what do I have over here? 2.54. So it looks like I'm doing E. What's the probability that a newborn fawn will be way more than 2.54? So give me this one right here. So what's that? So I guess we got to do this here. 3.80 subtract 2.54. I want to know how much do I have left over to get to what I need to get to is 3.8. So 1.27 divided by 1.7, technically are multiplied by 1 over 1.7. But on the calculator, much more easier just to divide by it, be done. So in that case, that is what I have on the calculator, and that is exactly what it says over here. So perfect. Okay, that is E. Okay, so I marked it now. All right, let's go to F. F is the one that was left blank by the person asking the question here. So the question is, what's the probability that X is going to be 2.2 or higher than 2.2, given the fact that we constrained our condition down to X being less than 2.4. So we're going to do the exact same thing here, 2.1 to 2.4 is our normal range. That 2.1 is coming from the original piece right over here. Our constraint came from over here. We're going from 3.8 down to 2.4. So if I think about what is the range right here, that'll be a 0.3. If you subtract them from one another, that's 0.3. So then the height of my rectangle will be 1 over 0.3. Okay, we got that. Now I'm going to put my 2.2 in here. And the question is, what's the area here? What's all this area right here? So if I subtract 2.4 or 2.2 from 2.4, I get myself a 0.2. That is the leftover area that I have. So 0.2 divided by 0.3, or multiplied by 1.1 divided by 0.3, and we get ourselves a 0.6 repeating. So 0.6666667. So the answer key says rounded to 4 decimal places, or the instructions say that. So in this case, we would put 6667. That'll be 4 decimal places with the extra 6 rounding off. All right, hopefully we're good. Keep on going. All right, this is question 12. So again, this whole concept of distribution of numbers, and what you want to focus on, is it uniformly distributed or is it exponentially distributed? That's the whole point here. Suppose that the time it takes my daughter Lizzie to eat an apple is uniformly distributed between 4 and 11 minutes. Okay, so again, it's a perfect rectangle distribution. And so what we got to do here, let's do C together. What's the probability that it takes Lizzie at least 9.2 minutes to finish off the next apple? So let's make our little rectangle. Start off at 4, end at 11. Make our little rectangle. That means that's a range of 7. Therefore, my height is going to be 1 over 7. Everything's good there. Now we put our little line and start cutting here. 9.2 minutes right there. And we're looking at least 9.2 minutes. So we're looking for that little piece right there. And again, notice from the previous question, the question after that, it's always the sort of same setup right here, uniform distribution. All right, if that's the case, let's go for it here. So we got to figure out the difference between 11 and 9.2. So 11 and 9.2, we've got to put a little extra decimal place here, and 0. So that becomes 0, that's a 10, that's an 8. Bring down the decimal point. Let's see, and then that becomes a 0 with a 10 and 1.8. So 1.8 is the range right over here. So we're going to take our range that we have divided by, or multiplied by, our 1/7, or divide by 7. And if you do that on a calculator, it turns out to be exactly what I want it to be, 0.2571 perfecto. All right, E on the bottom here. Let's see, what's the probability that it takes Lizzie fewer than 7.3 minutes? Ooh, this is a toughie here. Look, 7.3 minutes or more than 10.3 minutes. So we got to do like a left-hand side of it, and then we also have to do a right-hand side of it. Let's go for it here. Initial setup, 4 to 11. That makes this is 1/7. That's cool. I'm dividing by 7 again. And then we're looking at, let's see, 7.3 would be this way, going to the left. That's what I want here. And then 10.3 going off to the right. So notice we have 2 different spots here that we need to calculate. We need to calculate this part right here. In fact, I should add this in. Come on. All right, doesn't want me to add. So it's this little piece right here, and it's this little piece right here. So let's add the probability here. This is going to be the difference between 7.3 and 4. And if you subtract that, 7.3 minus 4 gives you 3.3. So that's all. Okay, got that. So it's going to be technically that. And then we have ourselves the upper end. So I need to know the distance from 10.3 to 11. That's pretty easy. That's just 0.7. So I'll give you the work there. Okay, so we're going to add this side of the probability as well as this side. We're going to keep the middle clean. We don't want the middle. We just want to take off the less than 7.3. We want the more than 10.3. So 3.3 here divided by 7 plus, that's the left side. And then the right side is would be the 0.7 divided by 7. Add those up in the calculator here and you should be A-okay. And it gives you exactly what I wanted to give you, which is 0.5714. All right. I think we're good there. Again, slow me down if you need to. Watch me again if you need to here. I'm going to go kind of quickly here to finish up. Next is number 15. And we got ourselves that little piece right over here. That's the issue. But let's go for a few things here. First is, let's go up here. So the cost of all maintenance on a car during its first year is approximately, oh, here it is, not uniformly distributed, but exponentially distributed with the mean of 158. The cost of all maintenance on a car during its first year is this right here. So then seems like it's a lot, it's gonna be a lot less. Let's see. You may spend a lot of money, but it's just shortened duration or a little bit of money. So we have this thing called lambda, and lambda really is just this little 158, and we take the reciprocal of it. So 1 divided by 158 goes inside there, and if you punch that in a calculator, you got what you need there. Okay, so how do we do this here? It goes like this. That's kind of what we're talking about right here. It goes like this. So 158 may be the middle right here. All right, so we have a lot of people spending a little bit of money, and then we have a little bit of people spending a lot of money to repair their car. That's kind of what we're looking at here. Okay, with these, there is a formula for them. Essentially I have built in calculators, online calculators to help you. The book does cover how to do and calculate it on a TI 83, 83 plus, 84, and 84 plus. So I'm not going to go into it because the book already covers it here. What I want to do is kind of go in through all the different other calculators that we have here, some of the calculators here. So if you go to our course and you go down on the homepage down to online calculators, that's what you want. Click on that. When you click on that, you're going to go to here called Exponential Distribution. There's an applet for it, and then there's just a website that calculates it. So both of those we're going to use right now. So click on the first one. This is the applet right here. And then there's a uniform distribution calculator as well. I kind of showed you the math way of doing it because it's just, in a sense, technically just easy. All right, let's go with it here. So we've got our lambda. Oh, there it is. Our lambda is 1 divided by 158. Got exactly what I need there. And then I'm going to put an X. And this one has a field that says either go bigger than what you want or smaller than what you want. So now we're going to go back in our notes here. It says, let's go back to the problem here. Sorry, flipping here. Larger. We're going to go probability the cost is larger than 1.181. So we'll go down here. Sorry, plumbing through this here. So that means our X over here has to be greater than this one. And if you click on that, leave this blank, you're just putting in the gray area and the blue area. And it gets you about 31% of the time a person's going to spend more than $181 to fix their car in their first year. Okay. Another way, here's your exponential probability calculator here. There's the other one, which sometimes I like this one better. This one has a two-tailed, which means you can kind of get two things in between. So what's the probability that I spend, I don't know, between $150 and $180. That's kind of this one right here. So it's the only, it's a website I found that does the middle portions here. Okay, so notice this is the left side. This would be less than $181. The right side is bigger than $180. So click calculate. And notice on this one, you're not doing lambda, you're doing just the population mean, just the average. And if you do that, you click calculate underneath it. It takes a little while, but boom, there it is. And we get the same answer. The only thing I don't like about this one, it only takes you to three decimal places here. 3 decimal place accuracy. That's my little issue with that one. Okay, but it does do this right here. So on the next one, it says, what is the probability of spinning between $147 and $168? So in this case, yes, you're going to do this one right here, the two-tailed test. Click on that, and it's going to give you 0.0491. This one it did give you. This time it did give you 4 decimal places. So I'm not sure why it does 3. Sometimes it does 4. So okay, and the last one on page 329. Here's what we have to do is we have to calculate I think it's let me just check. I think it's the 68th percentile. There you go. So in the book on page 329, it gives you the formula for percentile, or what number is going to give you a percentile of this much here. So the only thing that you got to do is the 60th percentile goes into this area right here. So if you're looking at the 60th percentile, you punch that in, and you have to subtract it from 1. And this guy's ln. Hopefully you've learned it in Algebra 2 or some other, or maybe intermediate algebra. You learned about ln. ln is a logarithmic function that is used quite a bit in mathematics. So let's subtract this. 1 minus 0.68 gets you a 0.32. And then we're going to bring this down. Now remember how we used 0.0063 earlier? That is an approximation. So I'm going to show you a quick little something. If you did calculate this, you get an answer of this much, $181.86. Only problem with that, this is not accurate enough. So when they tell you to put in what is lambda, and you put that into the first answer, or answer A, try not to use that again, because that's going to give you the wrong answer. It's going to give you $181. But so let me show you this right quickly here. If I were to do the same exact problem and I just kept that as 158, and when I punch this in the calculator, you have to learn how to punch that in the calculator, you get the right answer, which is $180. That little 3 cents, it's rounded off to the nearest dollar. So in this case, be very careful, especially with statistics. Sometimes the small numbers do add some issues there. So when you can, use exact values. That's kind of the lesson here. All right, so let's see. What is the number that gets you to the 68th percentile? It's going to be $180. Okay, chapter 6. That was chapter 5. Done. Chapter 6 is the normal distribution. So the normal distribution kind of looks like this. Let's start it here. Normal distribution, you've seen it most likely before. It has this little shape. It goes up like this and comes back down. It's like equal on both sides here. So let's go for it. So on a planet far away from Earth, IQ of a ruling species is normally distributed with a mean of 106. Pretty smart species. Standard deviation of 18. So suppose one individual is randomly selected from this outer space group. And let's go from there. So then the first question is, what's the distribution? And so this is what we plug in here. That 106 comes in from the mean, and that's standard deviation, right? That's normal for us. You should be able to do this by now here. That's the 2 numbers that we always need in order to start anything up. And so we go from there. So find the probability that a randomly selected person is over 94. So again, let's go back. The manual way to do it is something called a z-score. So there's my normal distribution. It goes like this. It goes up and comes back down. It should be equal on both sides. Just can't draw very well with my little ink pen. And the middle is right there. That's your mean. And the standard deviation is how far away we go from that mean. And so in this case, we want to know 94 right over here. Find the probability that a randomly selected person is over 94. So all this right here. So starting from here, then we want to go this way. So one little thing that we got to note is, notice we're passing the 50% marker. We're passing the 106. So anything on this side of 106, that's considered 50% of our little pile. Good. So then all we really need to do is calculate this much and then add 50% to that, or 0.5. So this little piece right here. All right. We can go like this. We can calculate something called a z-score. Let's do it manually, and I'll show you how to do it easily with a calculator. But I want to show you how this is kind of the process. And so this is before calculators were invented or very high usage. This is how we used to do it here. We used to take the mean minus here. Kind of, I needed this little spread right here. That's what I'm looking for right there. So 106 minus 94 divided by 18. And I get that. And then what I do is I go all the way to the back of my book, all the way to tables. When you click on it, you get student table, normal table, and that's what I want right there. We'll use the chi-square table and the F table later on here, but normal table, click on this little guy, and you get to somewhere over here. And notice what happens here. It just says the culmination distribution, and notice it starts again right at 50%, and it tells you a little bit more, right? It tells you a little more to go. So that's kind of how we used to do it. So when you calculate z, let me go back just real quickly. Let's see what the calculation for z was. Oh, if you calculate this is z over here, you should get an answer of like 0.666 or something like that. So what you do is you go by to this table right here. You had a 0.6 and you had a 0.66. So these are your tens place. These are your hundreds place. And what we used to do is to look to this table. There's my 6 right here. There's my 6 here. And I used to calculate this right here. So 0.24536. And we used to just get close. So notice ours is 0.666667, right? And so it's not quite 7. It's not quite here. It's not quite here. So we just went with the closest one. So what we do here. So, okay. So we used to do this by table. That's the way it was done, to the closest hundredths. We don't do that anymore. What we do in chapter 6 under normal distribution, we just go to a calculation table. So you still can calculate the z-score from an x table. That's exactly what we did on the previous slide. You can calculate an x value from a z-score. So going the other way, you can just calculate the normal distribution right away. And this one, you can calculate the percentage or the proportion value based upon a z-score. Now, all these are great. All these are good calculators. They do their job very well. And this one, these two just to do a better job. So we can kind of get to where we want to a lot faster. So let's click on this one, the applet itself. Applet looks like this. And so what we do is we plug in the 106, we plug in the 18, we plug in what we want. And then again, we got to choose. Do we want to go less than 94? Do we want to go higher than 94? And so in this case, we want Rx to be greater than the 94. So in this case, you click on this little toggle, boom, and here we go, 0.74751 is what we want, and we're done. So that's how much, again, that's how much area is covered underneath here rather than here. So about 70%, 74%, almost 75% of the data is covered in here, as opposed to about 25% here. Okay, so I got that one. Hey, there it is, got that one right. Okay, so now let's go the other way, I think here. The school offers a special service for all children in the bottom 4%. Ooh, this one's going the other way. What's the highest IQ score a child can have and still receive special service? So we want to know what's the highest, what's right at that 4% marker. All right, so let's go with it around to 2 decimal places only. Okay, let's go for it, but how do we do it? So let's go with it here. So click on this little guy called the normal distribution. Not the applet, just the normal distribution. And so what you want to put in here is you want to put in the 18 again, standard deviation. You want to put in the mean, and then you want to put in right here, you want to put 0.04. You want that 4% marker right over here. And you can leave this blank because it says enter whatever you want to calculate, just leave it blank. So click on calculate. And you got what you need here, 74.488. So we got to round it off to 9. So 74.48 is what we want. And that is the lowest, the highest score, right? The highest score a student can get and still be under that 4%. Okay, Then it says find the first quartile, inner quartile. So for that one, just change the 0.04 to 25%. 25% or 0.25. Leave this blank, click calculate, and you got yourself a 93 point, what is it, 86. And that's what you need there. And you're going to go right in here, 93 point, ooh, this one, the student missed this one right over here. So again, by that. And then you do the rest. You do the rest exactly the same way here. You click this, put 75% or 0.75 into the calculator there. And this range, so it looks like these numbers, the person that was doing it, they used maybe a different calculator, or because they got this one correct. So this 24.28 is just the subtraction of these two here. So what is this quarter 1, quarter 3 in your quartile range? This little piece right here. If we looked at the first, we chop off the first 25%, we chop off the last 25%, we just kind of keep the middle, the kind of like the half middle inside there, where most of the data is from. That's what you want. So in that range, so most of the people we say are between 93.86 and 118.14 of this species from a faraway Earth. All right, and the range there, the difference between the low and the high of that one is 24.28. Okay, fun problem. I liked it. So hopefully you learned something as well. All right, let's go with it. Next one. Now this one is question 14. I would just want to say that 15, 16, 17, the homework questions that came in of those, very, very similar. I mean, it's practically the same stuff, just a different scenario. So here it is. Suppose that a speed at which cars go on the freeway, so this is the on-ramp to the freeway, normally distributed. What we've been doing is we've been calculating, sitting there in the grass, and calculating how fast are cars getting onto the freeway as they're actually getting on the freeway. So we spotted, the average is 75. There's a standard deviation of 8 miles per hour. Okay, that's cool. Again, our distribution, there it is, the two famous numbers we need, the mean, standard deviation. So let's go with it here. So if one car is randomly chosen, hey, just like that one student, right, in the faraway Earth, find the probability that it is traveling more than 77 miles per hour. So think of which calculator you need. Jump to it. I'm going to use the normal distribution app, the applet for it. Again, 75. We're going to go with the 8, and then we're going to go 77, and we want the greater than. I'm looking for all the x's that are greater than 77. Clicking on that, that's about 40%. So 40% of the cars that we saw or should see are going to be going 77 miles or more. Cool. All right, this one, I think, let me jump back. I think this is saying how many cars are going over 81 miles. So kind of going a little higher here. So again, still the same applet. You just punch in the 81 and you're going to go with our x's, all the x's that I want that are greater than 81. And it's about 22.6, source 22.7% or 0.22663. Okay. Oh yeah, sorry. So this one right here. So it is, let me go back real quick here. Don't want to screen freeze you here. So this one right here, there it goes. If one of the cars is randomly chosen, find the probability that it is traveling between 77 and 81. Okay, so this one, I want this one still. I want this guy here. But then I want to chop off anything that's above 81. So I want to in between 77 and 81. There you go. That's what I want to do. Okay, so let's go jump to it. So at 77, we have about 40% of the cars that are going to go above 77. But at 81 right here, I want to get this little middle section. So what I want to do is I want to chop off anything that's above 81, all this little probability over here on this side. So I figure out 81 over here. And then over here is my 77. 77 is about right over here. Here's my 81 about right here. And I want to subtract this part from the previous one that I got. And that'll give me my middle section right here. So my 40% or so, subtract what I got now right now. And if I subtract it, good, I get what I want, which is about 17%. About 17% of the cars are going to be going between 77 and 81 miles per hour. All right, that translates. I think we need 4 decimal place accuracy, so 0.1747 is what I got for the answer. All right, we good there. Let's jam to the last one now here. So 82%. So this one's a little going backwards here. So let's talk about this here. So far we've been getting the percentage. These guys are all percentages right here. So that's 40%, that's 17.47%. This one tells you I want to go backwards. I want to go, if I'm at 80, I want to figure out 82% of the cars will be at least how fast on the freeway. So I know my percent, I know my proportion. I want to know what the actual miles per hour are. And so this person here, as they were doing the exam, they got it wrong. It should be 67.67 miles per hour. So let's see, how do we do that? And so let's jam to it here. So notice that at 81, it's 22%. So notice that at 75, that's going to be already 50%, right? But it's saying how fast is it if it's going, if we want 82%. Okay, if 82%, that means I have to include all these guys here. That means I have to include more than 50%. I'm going to be like somewhere like in this range over here, because that will be about, if I color all this in, that would be about 82%, somewhere in here. So, okay, how do I calculate that? So this is going the opposite way. And so to go the opposite way, I'm going to go back to this little munchkin right here. And what I need is, I know this. So I got 75, I got 8, I got, and then I'm going to punch in this. Only problem is, you're not going to punch in 82%. What you're going to do is you're going to punch in 100 minus 82%, or 18. So you're saying, what's my probability of less than? It's a less than marker. So you can't say what's happening on this side, on the right side. What you're going to do is, okay, how much is from my 0? How much do I want to come up, and where do I want to cut it? My cut's going to happen, if I want 82%, my cut's going to happen right at 18%. And I'll cut all this off. And so if I do that, click on that, leave this blank, click calculate, boom, and you should get exactly our answer, 67.677. All right, hopefully that was helpful. We are jamming to chapter 7 now. Chapter 7, here it is. We have ourselves, let's see, normal distribution. What is chapter 7? Chapter 7 is the central limit theorem. Okay, so that's cool. Central limit theorem. Let's go with it. So suppose that the average number of Facebook friend users is normally distributed with a mean of 138 and a standard deviation of 40. So let's talk about it here. Assume 17 individuals are randomly chosen. Answer the following questions around all 4 decimal places when possible. That's great. Okay, let's talk about it here. So the average, 134, goes right inside there. That's all good to go. The standard deviation is different. Okay, it's different because we are looking at this group of 17 individuals. So there's a little bit of error that's going to happen. And so what we do is we go back over here. We understand the fact that if you have a sample size, there's going to be a little bit of error inside there. And so with the standard deviation of 40, what we do is we take that 40 that we have for the population, we divide it by the square root of the number of sample sizes there. So 40 divided by the square root of 17 gets you the 9.7014 that we want. Cool, now we're dealing with a group of 17. Let's go for it. For the group of 17, yes, which is this stuff. Find the probability that the average number of friends is less than 127. Less than 127, okay. So I'm looking for probability. I'm looking for a percentage or a decimal approximation, right? So I'm going to go back to my calculator. So I go back to my calculator. I punch in 134. I punch in my standard deviation, including sample, right, of the 17. And I punch in 127. This time I want to go all the x's that are less than 127. So I'm going to flip this little key around. Boom, click. And I got this right here. It shows me, the graph shows me exactly what I want. Yes. I want the area right here. That's what I want. And the area is 0.23529. Okay, then it also says find the third quartile. The third quartile. So I'm going to go to this guy here. And so let me go back real quickly here. Let's see. Let's find the third quartile for the average. So notice here, I'm not trying to find, again, I'm not trying to find the probability. I'm trying to find the value. If I'm trying to find the value, I'm going to go to this little piece here. All right, punching 75%. And we get ourselves 140.544. So all we need to do right there. Okay. So I just kind of put in a couple more normal distribution calculators. I thought they were just a little bit better. So if you want to check out those, so another normal distribution calculator, and then the inverse, just kind of find a better one that kind of just gives you, going backwards, it's a lot easier to sort of think through there. And so clicking on that one. So this one, you can do same thing here, 134. You click on this, you click on the 75 percentile, and you click calculate down here. And it does take a little bit of a while, I'm not sure why, but then it calculates it, and here it is, 140.5036. And good. Sorry, class, let me check out something real quickly here. 544, and this one gives you 5454. So this one actually gave you 4 decimal places, and I think that's the reason for it, because on the instructions on this, it says give 4 decimal place accuracy, I believe. And so with that one does not give you 4 decimal place accuracy. Sometimes it does, sometimes it doesn't. I'm not sure why. Anyway, I want to see you guys, show you the graph of it as well. So that's kind of what you're looking at. You're looking at when this is the 75% cuts off right here. So right here is 75% of the data. This right here is the 25 top percent. Okay. Number 17, a lot of stuff happening here. So let's go with it here. Now this one, again, there's other homework questions that are very similar to it. So I'd let you guys just try it here. So the average score for games played in the NFL is 21.3. I did not know that. That's pretty cool. The standard deviation is 8.9. That's cool. 14 games are randomly selected. So notice it's very similar to the ones that we just did here. There's a couple more. There's something called the summation distribution, which I wanted to cover. So round all numbers to 4 decimal places. Okay, when possible, and assume a normal distribution. That's great. Let's go with it here. So what's the distribution of the average? Let's go for it here. So this guy, average comes in as 21.3. Boom, done. 2.3786. Where does that come from? It comes from this again here. So the distribution of the population divided by the square root of the sample size. So square root of 14, punch that in, and you get yourself that right there. Then the question is this: it's the distribution of the summation of x's. So I want to see that right here. So all really it is, because we have 14 games, we're just going to multiply that, the average, times 14. That's kind of what we do there. So we take that 14, multiply it times the average, and we get ourselves what we need right over here, 298.2. And then for the standard deviation of the summation, we just take 2.3786, multiply it by 14. So when we do that, we get ourselves what we need out of this, which is 33.3004. So good there. Okay, so let's take a look at it here. So find the probability that the average is going to be less than 21.8321. Okay, we'll go with that. Find the 69th percentile. Okay, so notice this one's going backwards, right? We know the percentile, we know our proportion, and we want to go to the answer itself. Then it says find the probability that the average is between these two scores. Okay, gotcha. We'll figure that one out. The student here asked the question, figured it out as well. Find the 75th percentile for the x distribution. This person left a blank, that's okay. And then here it is, there's summation that we've got to use these guys. So notice the summation, it's just the addition of all of them. So let's go back real quickly here. So probability of P. So we're going to use these numbers up here. We're going to use the numbers from A right here. So punch it in. So I'm going to use my applet again. There it is, 21.3. There's my standard deviation. I'm going to punch in this. And I'm going to say it's going to be X. What that I want is going to be less than that. So I just want to make sure here. Yeah, there it is. And just that symbol should be the same. So X less than that right here. Punch it in and we get exactly what we want. 4 decimal place accuracy would be 5885 would be good there. Done. I just like this little app. I think it has a good little feature there. Okay, so let's go backwards. So here's a go click on the inverse normal probability calculator. That's the one. I thought this was more straightforward, a lot straightforward. You plug in your mean, plug in your standard deviation, you plug in the percentile that you need to get to. In this case, 0.69. Click calculate and blah, blah, blah. It gives you exactly what we need, which is 22.4795 is what we got here. So do that, that's cool. Get ourselves what we need. Whoa, and this is kind of funny. Right, and let me go back real quickly here to a few things here. Here's the reason why I got this one all set up for you. Sorry, going back here. This one, another normal distribution calculator. This is where I got stuck a little bit here because you can do it the old way of trying to subtract one from the other. But if you're trying to figure out the average between these 2 points right here, I found a little applet that allows you to do that. So let me run through this little piece right here real quick here. We already did that. So we'll go over here. So this another normal distribution calculator. Punch in the mean, punch in the standard deviation. This one's kind of cool because it gives you above, below, between, and it also gives you the outside. And so what you want to do is you want to click between. You punch in the numbers exactly as they appear on the little piece here. So what you really are doing is you're trying to figure out the area. What's the area right here of this? And so clicking on that, click calculate and get yourself 0.399. Right there is all we need. Punch it into your answer and we're good to go. Then it says plug in to find out your let me just check real quickly here. Oh, the summation, that's right. It was the summation ones here. So I would use this calculator again. It's the summation of X. So 298.2, this is part B now, right? When you're adding all the X's. Standard deviation was 33.3005. And it says, what's the probability of it being below 335.0494? So click on below, click calculate, and it should give you the answer right here, 0.8635. So notice it's way over here. The average was 298. So if you're saying, what's the probability that it's going to be below 335? Well, it's going to encompass the average and everything else below it as well. So it should be above 50%, and it looks right. It is. Okay, so we got that right here. We got Q3, that was that 75% that we did over there. All right, and assumption for part C and part E is assumption of normal necessity. And yes, it is, yeah, because of the sample size. That's what we need. Okay, chapter 8, last chapter, here we go. And so question 11, some students had some trouble with that, so I decided I should give you that one here. So Professor Smith loves dark chocolate. He is like me. And he would like to find out the proportion of the population that shares his preference. So he randomly selects 600 people. 221 people choose dark chocolate already. And he wants to construct a 95% confidence interval. And so chapter 8 is about intervals. That's cool. So question is, what interval or what should he use? So what should he use? Okay, the only problem is with intervals here, with these two right here, you would have to know the average already. And you have to know the average of the population. Something similar to the what is it? The football stuff that we just covered in the previous chapter. All right. So then it's kind of left with these guys here. So two sample means you're judging two things against themselves, and you're not. So it goes down to this one right here. And it goes on to just, it's a Z proportion, and it's a proportional z interval. That's what we're looking for right now. The reason for it is because you're looking at a proportion of people that like or dislike. It's a yes or no vote over here. It's a success or not success. That's kind of what you're looking at. Notice that there's no average here. There's no standard deviation. There's no nothing that's given here. All right, and then it's a z interval because the sample size is large. That's 600 people that are using it. So there's that one. Okay, and on to the last question, I believe. So here it is. Let's go with here. Smartphone manufacturers interested in constructing a 99% confidence interval proportion of smartphones that break before the warranty expires. Very similar. This is very interesting because warranties just keep on popping up all the time, and they're calculating this right here. So 95 out of the 1,510 randomly selected smartphones broke. Okay, around 4 decimal places. So with 99% confidence, find the proportion of smartphones that will break before the warranty expires is between what and what. So the answers are right here, but how do we find them? Let's go with it here. So what I did is I had confidence intervals here. I got the Z confidence interval, the T, and then I decided I better should give you that one here. So this is the one proportional Z interval. So clicking on this, if you click on that, you can have how much decimal place accuracy you need as well. That's kind of cool. Let's see. So we're looking at 99% confidence interval. We have to give the sample size. And then we have to give the percent success. So this is the 95 divided by 1510. So this is 95 divided by 1510. What's the success that happened of the people that did like dark chocolate? So plug in those values, click that, and you're good to go. So we've got a few things here. There's the Culper-Pearson model, and we're not going to use that. There's a normal approximation. We are going to use that. That's the one that we want right there. So we are saying that about 4.6 or 4.7% of the phones are going to break before the warranty expires. And the back end, these ones are hardly ever going to break here. So there's that little piece there. So it's these numbers right here. Judge it to 4 decimal place accuracy. So 1, 2, 3, 4. So 0.04, 0.0468, 0.0790. I guess we'll now look at that. Okay, so let's go back to our final answer here. And that's 3 decimal place accuracy. That's, oh yeah, because there was a 0 behind here. That's fine. Okay, so then it goes kind of backwards here. So what percent? 99%, since we left it, what percent of these confidence will contain the true population that break before the warranty expires, and about 1% will not contain the true population. So you're looking at a 1% failure rate based upon those models. Okay, I hope you found this useful as you guys preparing for the next exam, and I wish you well in the exam.